So constraints from Big Bang nucleosynthesis, from Type 1a supernovae surveys, from the cosmic microwave background, and from many other sources have been put together into this best fit that tells us the parameters of our universe, which I used as input for my description of the history. So let's see how these parameters are put together. What we see here is a plot of matter density today versus cosmological dark energy density today. The line here is the line diagonal where the sum of the two densities is 1. Remember, that's total energy density 1. That corresponds to flat universes. Above it, we have positively curved universes. Below it, negatively curved universes. And these concentric curves are curves of within which, outside of which, you can exclude being with increasing certainty based on various measurements. So, for example, the supernova survey, remember, was measuring the deceleration parameter. If you remember, that corresponded to rho plus 3p over c squared, which ended up being a half of the density of dust plus the density of radiation, which is irrelevant, minus the density of dark energy. And so that's the slope of this graph. We get a very good measurement of this quantity in this direction, but we get a less of a sensitivity to the sum of this plus that, because if you increase the matter density and also increase the dark energy density, the deceleration parameter doesn't change much. So the supernovae give us a good constraint in this direction, but not much in this direction. On the other hand, the cosmic microwave background data is pretty much sensitive to the total density. Remember, we measured the flatness of the universe. It lays us pretty much on this line. Happily, these two are crossed, and so between them, they produce a very good prediction. This is additional data sensitive mostly to the density of dust, because this has to do with looking at the galactic distribution and correlations in distances in that, similar to the way we studied the acoustic sound waves in the primordial plasma. And again, this is supposed to track the wavelengths of fluctuations in the dark matter density, and so this gives us a third and consistent constraint. There are many other observations that go into the pot when making our best estimate, but you see that we have both consistent and rather precise determination of the parameters of our universe, and you see that we predict a dark energy of about 0.75 of the critical density and a matter density of about 0.25 of the critical density, of which, remember, we have restrictions that say at most 5% is visible matter, so the rest, or baryonic matter, that's from, among other things, baryogenesis and also the details of the cosmic microwave background. So we predict that the rest is dark matter, and we do know exactly what our universe is made of. That's quite exciting.